Problem number 1. Use data below to determine the reaction that best describes the reaction between acetic acid and sodium bicarbonate. Mass of NaHCO3 is 2.03 grams. Mass of reaction mixture at time 0 is 50.93 grams, and mass of reaction mixture after reaction is complete is 49.79 grams. So we have some possible reactions. Here are our possible reactions. Let's start by subtracting from our mixture at time 0 our mixture mass after a reaction is complete, giving us the grams of, quote, lost CO2. So to find out the mass of the CO2 produced, all we have to do, because the lost CO2 is the CO2 that is dissipated in air, but it is CO2 that was produced, so we must change that from grams to moles, and that's how much CO2 was produced. And we will save that number for later to compare it to numbers that we will find in a minute. But first, we're going to convert the grams of NaHCO3 to moles of NaHCO3, and we get 0.0242 moles of NaHCO3 to start. For each possible reaction, we're going to find the amount of CO2 produced. So, for A, we will we'll start with our moles of NaHCO3, and then we will use the 2 moles CO2 per 1 mole NaHCO3 ratio to find our moles of CO2 produced. And then we will do the same for B, except the ratio will be 1 mole CO2 to 1 mole NaHCO3. And then C, once again, we'll do the same thing, starting with our 0.0242 mole of NaHCO3, except the ratio will be 1 mole CO2 to 2 mole NaHCO3. Now remember that number I said we were going to save, which is the amount of CO2 produced according to our calculations. We look for the one that is the closest. It doesn't have to be exact, but the one that is closest, and therefore the one that best describes the reaction. Meaning the answer is possible reaction B. Problem number 2. Of the 3 suggested reactions below, based on your chemistry knowledge, which should be the correct reaction and why? And let's put in our reactions here. Let's start by writing down the start. So put HC2H3O2 plus NaHCO3. We're going to leave space in case we need to put any numbers in front. And then we're going to put, since I believe this is a double replacement, we are going to put reacts to form H2CO3 plus NaC2H3O2. So now that we have switched them and, moved the things around so that, the H's are together, we see we have H2CO3, which would decompose to form H2O and CO2. And now all we have to do is balance the equation. And I see 5 H's on both sides, 3 C's on both sides, 5 O's on both sides, and 1 Na on both sides. This means that the reaction is already balanced, and as we can see, this is the exact reaction for reaction B. So reaction B should be the correct reaction. And to answer the last question, some likely sources of error would be spilling when you're measuring things out, things getting maybe stuck to the containers, and basic human error in calculations, using the wrong numbers, wrong significant figures, and doing it in the wrong order. All these things could contribute to different results in your experiments.